Welcome. I'm going to be going through the 2018 past paper, which I've been advising people not to do. And that's because the language in the paper was quite complex. Certainly from what they've told us at conferences, I believe that, we'll get something, but we won't get a paper with language that's quite as confusing as this, although, there are no guarantees. If you recommend doing the 2019 past paper, because that's a paper that's the current examiner set, and I think the language there was far simpler to understand. So basically, we've got a city with a bus service that has a whole bunch of stops, and we have bus routes, each visiting a number of stops. And I think perhaps the point of confusion comes in that you might think automatically that what you do is you have a route, and then each route would have a whole bunch of stops stored in it. So you'll have a route object, a whole bunch of stops, and that's how you determine things. Or you're going to get a file with the route, and you have a whole bunch of stops. Whereas in actual fact, what happens in the file, and I think you need to create that, but what you get in the file is you get a whole bunch of stops, and the stops say which route they're at. So rather than the file saying route 1 stops at stop A, B, C, and D, you get something where you get stop A is visited by route 1, 5, and 7, and stop B is visited by route 1, 7, and 9, or whatever. And you then need to go through each of those stops to determine and build up routes from that. Okay, so we have a stop, and it's got a stop name and route codes. And this is the route in which the stop is listed. So it's a B, R, P, Y, and any combination. So those are our routes. We've got routes B, R, P, and Y. And you can see what I mean, how basically so there's going to be, like, say, 20 stops, and then you need to go through all 20 stops, and you need to see wherever there's a B, and then that way you'll know what route B consists of. And then there's a stop type, which is 1, which is a cafe, 2, which is a shelter, 3, which is an express, 4, other. And the class stop has 4 constant static variables to represent the 4 stop types mentioned above. Those are important. We then have our data.txt, and that contains information about all of the stops shared amongst all of the routes. So each line contains information about one stop. And it is really important that you look at the text file. So stop name, that's the first thing. So our first stop name is called Waterfront. Then it's a stop type, which is a 1. So this, for example, would be a cafe, and then the route codes R and B. So the Waterfront is visited by routes R and B. St. Monica's Cathedral is visited by routes R. So you can see, if I go through this manually, route R goes from the Waterfront to St. Monica's, the Conference Center, CC, whatever that is, to the Market Square, and then that's it. Route B goes from Waterfront to Market Square to Grande Hotel, and I think that's it. So if you understand the text file, and it's really important in your reading time to go through and look at the actual information and understand it. Don't just skip it, actually read through it. Then it does become a lot easier to do this. A class will have to be created to represent routes. A route is made up of multiple stops. And I think here is where everyone was thinking, oh, I'm going to read in from the text file, I'm going to get a route in our list of stops, as opposed to the other way around. Some routes are circular, and that just means you go back to the original. So if route B was circular, we'd go Waterfront, Market Square, Grande Hotel, Waterfront, Market Square, Grande Hotel, etc. And some of them are linear. So basically you go all the way in one direction, and then you go in reverse. So if this was a linear, I'd go Waterfront, Market Square, Grande, and then back to Market Square, Waterfront, Market Square, Grande, Market Square, Waterfront. And that's what they're showing you. Yeah, you go stop, 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 and then back. Cool. Right, each route is the following information. There's a route code, and that's going to be our B, R, P, or Y. Whether the route is circular, so that's going to be a Boolean, because it's like, if it's not circular, it's linear. And then an array of stops that form part of this route. They should be listed in the order they are visited, starting with the departure stop. Each stop should appear only once. So we won't do things with our linear where we go, if you're going 6, 7, 8, 9, you just show those first things. You won't show the journey back. And the array of list stops only lists the stops relevant to this list. Routes, not all the stops listed in the text file. And the scenario given must be used to answer question 2 to 7. So question 2. So for the first couple of questions, you're going to have a UML diagram and questions. Do them in conjunction. Okay, so there's our diagram, which indicates properties and methods. Take careful note of method and parameter names. you must name your methods the exact same as here. And if you're given parameter names or fields, you must name them the exact same thing. No additional public property or method should be created. You may create any additional private property or method as needed. I think the memo uses a little trick with the private thing. I may or may not do that. We'll see. Okay, so question 1, create a new class called stop. That should not be beyond any of us. So file, new project, and I'll just call it prac IEB prac 2018. I'm going to untick create main class because our main class is only going to come much later. Source package. Let's create a source package. I'll call it whatever. You could probably get away without this IEB prac. And then just create. It does moan at you if you don't put things into a package, but it still works. So you can just do what you've been doing. So there's our class stop. And I'm on 1 out of 80 already. Create 3 properties to store stop name. One thing I do want is if you've got like your name there, actually you won't, it'll be the exam thing. But yeah, don't put your name even in the comments. Okay? You can create 3 properties to store stop name, root codes, and stop type. So let's do that. What I am going to do is over here, I would type my exam number if I had one, but I don't. So we'll type my exam number there. And then this is question 2.1. They did ask us to comment on our questions. Question 2.2 is to create 3 properties. So this is so constants are always going to be public, static, final, and then it's an int and stop type underscore cafe equals 1. A little bit tricky to read here that that's an underscore there. You kind of have to note. You can see over here that there's an underscore. But I could see people getting a little bit confused there. Once again, constants have to be public, static, and final. You must put the keyword final. You'll see if you don't put the keyword final, you lose marks. Cool. So this is stop type shelter and then stop type express. If you are going to copy and paste like I am doing, make sure that you don't mess up and that you change everything correctly. Otherwise, you're going to lose marks that you shouldn't. There we go. And that's question 2.2. That's not 2.2. That is 2.3. I'm an idiot. Do read the question. Question 2.2, 3 properties. So I've got private, and I know it's private because I've got a little minus in my Uml diagram. It's a string stop name and private string root codes, and finally private int stop type. Cool. Question 2.4, create a constructor method that accepts 2 strings and an integer as parameters. If you've always been inserting your constructors, you absolutely must rename everything to be exactly the same as those. There's no need to insert a constructor because it's dead easy. 2.4, so it's public stop. It's always the same name as the class. And then, look, they give it to us. It's string in stop name, string in root codes, and then int in stop type. Okay, and then basically it just says the 2 string parameters represent the stop and the root codes. The constructor should do the following. The 2 string parameters must be used to assign the values of the stop name and root codes. So stop name equals in stop name. So do make sure you don't get this the right way around. So like your, the class field stop name is green, needs to come before the local parameter, which is in black. If you look at the trees outside, their leaves are green, and only much later on are they going to fall down and turn black and decay. So there, remember, green comes first, then the black. Okay, and then root code equals in root code. I'm just checking out, it is meant to be root codes with an S. Okay, and then the integer should be used to represent the stop type and must be one of the values of the static constants. if the given integer parameter is not one of the static constants, then the stop type property should have its value set to stop type other. Okay, so basically what I want to do over here is I want to say something like if in root code is equal to 1 or, okay. Basically, if it's 1, 2, or 3, I can just set it to be 1, 2, or 3. And if it's anything else, I'm going to set it to other. They did get a little bit fiddly with the memo here. If I look at the memo, let's just open up the memo. Just so I make sure I don't lead you down the wrong path here. So it's over here. If you take a look, oops, we're going way too far. Okay, so basically, comparison correct, check against constants, and use OR correctly. Okay, so you have to, if you look at this, so if I do something like this, so I say if in root code is equal to 1, or in root code is equal to 2, or in root code is equal to 3, my code will work. Okay. However, I will end up losing a mark because the reason we use I've gone wrong somewhere. I'll figure it out. Anyway, the reason we use in root code is an int, isn't it? I'm an idiot. I'm an actual idiot. In stop type. There we go. Sorry. So if in stop type is equal to 1, or in stop type is equal to 2, or in stop type is equal to 3, the issue with that is if you ever change the constant, so for example, if I needed to, I don't know, for whatever reason, I wanted to use a different number, or like 5, because maybe I added in some extra stops or something, all of these numbers would have to be changed then, which would get around the point of using a constant. The reason to use the constant is because if you change something, then you never ever have to change it anywhere else. So you'd have to go if in stop type equals stop type cafe, or it's equal to stop type shelter, or it's equal to stop type express, then basically root code stop type equals in stop type. Else stop type equals stop. Well, okay, I can just make stop type other. I was going to say I can type before, but I can't because and this one is going to be quite easy because if I added in a fifth type, so let's say I decided that we were going to have a I don't know, so a cafe, shelter. Let's just say that we had a restaurant. That would be 4, and then I'd make stop type other 5, and that's why you can't just say if stop type equals, stop type equals 5 or whatever. That's why you do have to use the constant there. All right. So that's the constants. That was the one thing that I think people might have found slightly confusing. I don't want the memo, but I think it's your question paper. Right. Cool. So that's my constructor done. Create a method name type to get stop type name that returns name of the stop type. So if the stop type property has the same value as stop type cafe, the method should return cafe. And once again, you're going to see that we need to compare against the constant. I mean, that's why they specifically said over here, questions here, sorry, but if the stop type has the same value as stop type cafe. So that's a clear sign there that I can't go if stop type equals 1, return cafe. It has to be if stop type equals stop type cafe. Okay, so let's just do that. And this is question 2.5. And I'm going to go public. I'm going to just double check against my UML diagram. It's get stop type name and it returns a string. So a public string get stop type name. And then switch stop type. It's just quicker than doing a whole bunch of ifs. I don't think they would have taken marks off if you didn't do that. There is no colon there. It's my mistake. What it is instead is that. And so it's case stop type cafe. I return, and I think they wanted me to return cafe. Break. Don't forget your breaks. Very important. Case stop. Actually, you don't have to break because we're returning. Ordinarily, you would put a return a break there, and it would be very important. But because we're returning, you'll see in fact what the error message is. If I put a break here, it's actually going to say this is an unreachable statement, and that's because the only way you get here is by going into this case, and here this tells us to return, which leaves the method, so you can't possibly get to that break, and that's why we don't need to break in this one specific instance, because we are returning. If we weren't returning, we would absolutely have to. Imagine express is just express. And then I'm not going to check if it's stop type other. It says for any other value of the stop type property, the method should return other. So I'll just go default return other. Cool. Create the method is part of root that takes in a character. The method should return a boolean to indicate whether or not the stop is part of the root represented by the given character. And here I think people get confused. What's going on? And what's going on is that if you take a look over here, my stop type will have the root code R and B. And what I want to do then is, if I send an R to this method, I want it to say, yes, this is part of the root R. If I send it a B, I want it to say, yes, this is part of the root B. If I send it a Y, I want it to say, no, this is not part of root Y, because there's no Y in the root code. Okay, and you need to do any way of going through this. If we take a look at the memo, I think they're given a couple of alternatives here. You can see they're just doing .contain, so you're perfectly able to do that. I know in grade 11, I said rather, get a feel for how everything works, but you're absolutely welcome to use contains. And then also you can see they can do use an index of to search for the character, and they don't have a for loop. I thought they might have a for loop where they go through every character and compare it to the one, but that would have been acceptable as well. Okay, so let's take a look at that. So this is question 2.6, public. What am I looking for? I keep forgetting where the question paper is. So public, and there's our, once again, I want to just double check over here, is part of root. It takes in a char and it returns a boolean. So public boolean is part of root, takes in a char. They don't specify what it is, so I'm just going to call it in char. Here you can make it your own name, give it a decent one. I don't char. I don't want to call it in root code because then you might get confused with that and root code. So there we go. So all I go is if root codes dot contains in char, return true. Otherwise, we're going to return false. And char can't be converted to char sequence. So I suspect if I just do that, that's going to work. So you'll see that a couple of methods, if you need a string and you're giving it a character, just do what I did there, append an empty string, and we're good to go. I don't need to have an else or anything because once again, because we're returning. So it's not like any other, if it's true, if statement evaluates to true, we're going to get to this line, we're immediately going to return. It won't do anything else. So I don't need to worry about putting this in an else. And I don't need to say, well, why are you just returning false? What happens if it's true? Because if it was true, it would have been returned there. So that's why you can make this method exactly that compact. Create a toString that can be used to output a string representation of the stop instance that includes the stop name and the stop type name in the format. So question 2.7. So public toString, and I want to, so this is just going to be return, and because I don't have to do a for loop or anything, I can return straight away. So I want the stop type name, which is going to be my get stop type name, forgot to go public string to string. It does return a string. Stop public get stop type name. I think that's true. Yes, it is. That's correct. And I want to add a tab, and then I want to add the stop name. This is not set stop name, it's get stop type name. There we go. Cool, and there we go. That is 23 marks out of 80 already. So question 3 is now the route. So the class will be used to store the details of the bus route. The diagram indicates the pub. Once again, it's the same as we read earlier. So we've got char for route code, a boolean for is circular. So it's true if it's a circular route and false. That's what is circular is. And I think I actually want to let's talk about these names here. Is part of route means whatever argument I send it. So if I send it in char, it wants to know is in char part of the route. That's what that is thing is. So that you can also try help understand, try and understand what things are doing by looking at the actual names of the methods. So anyway, we've got route code is circular, stops, an array of stops here. And again, I think this is where people thought, okay, I'm going to read in from the text file and put them all into here, but it's slightly more complicated than that. Set stops, and this here is our indication, and you'll see that we actually don't do anything with the stops field at the beginning. We leave it for later, and then later on we use set stops to actually set that parameter. And you'll see over here that your constructor method only takes two things, for route code and is circular. And they have unfortunately given the same name, so I'm going to have to show you, I'll show you what we do there. Okay, and get stop at int num. So this is going to say get stop at a position. So we know we've got an array of stops. So we basically go, in our array is going to have position 0, position 1, position 2, position 3. And then basically, so this is going to be like, over here will be like the waterfront. Then maybe stop 2 would be the cathedral. And then maybe the next one would be the CC or whatever it is. So if I said get stop at 2, it would give me the cathedral or whatever I said was going to be at stop 2. And then a toString. So create a new class named route with 3 properties indicated above. You'll see you no longer get a mark for creating a class. We've already given you 1 mark, or we've acknowledged you can do a class. So once again, I don't want my name there. But what I do want here is my exam number. And then question 3.1 is where we actually create the properties. So I'll put it over here. So question 3.1, private char route code, private boolean is circular, and private stop array called stops. Again, I'm not going to give it a size here or anything until they tell me to do anything like that. And you'll see, in fact, this is one of the few times we don't have a size. So question 3.2. Create a constructor method that accepts 1 character as a parameter representing the route code, and a boolean representing whether or not the route is circular. The constructor should use the given parameter to set the route code and is circular. And you'll notice they've typed in the exact same name here as our field. So when I do this, when I go public route and I go char route code, and then boolean is circular, you'll see if I start typing anything about route code, let's just say route code equals L, which you wouldn't do, you'll see it immediately goes with the black route code, the parameter. So if I type something like route code equals route code, it's not going to work. This is going to say that parameter equals the parameter, and we have to have a green followed by black. So to get the green in this case, because it's got the exact same name, and I want the route code belonging to the class, I type this dot route code. Similarly over here for the next line, no, I can't get to the end there. I go this dot is circular equals is circular. Okay, always green, then black. And that was it. Those are the 2 marks. This property stops should not be set by the constructor, as it will be set by the set stops method. Create a set method for the stops property that accepts an array of stops as a parameter. And here we can see set stops takes an array of parameters, and they called it S, so I'm going to call mine S. I don't know why they gave a the variable name there, but they normally don't for those, but they did, so I have to stick to it. So public set stops, stop s, and I say stops equals s. Notice I didn't have to say this dot stops equals s because they don't have the same name, and this is just a void. Right, and I forgot to type the question number. This is Q3.3. 3.4, create a get method for the property root code. So public get root code is, it returns a char, so char get root code. And this is just going to return root code. And then create a method called getStopAt. The method will accept the position of a stop as an integer and return the corresponding stop object in the array. It should return null or null if the position given is not valid. Okay, so because we don't have a variable for size, because normally, like if I had like a size method that would keep store the size there, I would be able to compare the integer, so it's public getStopAt, and they've called it int num. And this returns a stop. So if you take a look there, it returns a stop. So what I can do, I won't get full marks of this, but I could just go return stops num. So that will return the thing there, but that won't be doing the checking to see. It's going to return a null if the position given is not valid. And the way we have to do that is I say, because I don't have a size variable to do it, I need to say if num is bigger than stops.length, return stops.num, else, I don't even need an else, I can just go return null. Putting an else there would be fine, and that should give me the full marks. Let's just compare it to the memo to see if there's any little fiddly things that talk about. Nothing there, nothing there, nothing there. Oh, look at that. I didn't think about what happens if they give us a negative number. That was silly. That was silly of me. So if num is greater than or equal to 0, sorry, no. Oh, I'm an idiot. This should be a less than. Okay, sorry. So, okay, if num is greater than or equal to 0 and num is less than stops at length, return stops at num. Okay, so I didn't really think about that. Okay, and otherwise we're good. This is over here if you started counting at 1, which we are not going to do, so don't stress about that alternate solution. All right, and let's go back to the questions. The toString will be completed later in question 5. And you can see over here on the memo, if you look at the memo, you can see that they actually labeled it as question 5 later on. So I think we're done with question 3. So let's take a look at question 4. So question 4, create a class named Tour Manager. We're back to getting a mark for creating a class. So Tour Manager, once again, I do not want my name there, but I do want my exam number. So create a class called Tour Manager. So I'm going to call this question 4.1 over there. And then declare the following array and counter variables. And we now no longer have a UML diagram, so I have to do these myself. An array that we use to store up to 100 stop objects. So private stop, I'll just call this stops, equals new stop 100. I think I'm just going to pause the recording quickly while boys are moving outside. Okay, I'm back. So we're now on Tour Manager, well, question 4, although you still know that. Question 4.2, declare the following array and counter variables. I think that's what I was busy with. I got confused, but I didn't see a comment. So it was 100, and then a counter variable, so private int size. And we can give it a value of 0. Right. Then create a constructor method that will read the contents of a text file containing the information of all the stops. This, by the way, is where you would do that. So you go to your learner files, section B, and then probably, honestly, the easiest, rather than going to manipulate it, I think is just click on the Files tab, and you want to put it under IEB Prac 2018. Okay, so it must be in this folder here, IEB Prac 2018, not in the SRC folder. Okay, so question 4.3 was a constructor. So I'll go public tour manager. Okay, and this is relatively straightforward and standard. The constructor must taking a string representing the file name, so I'll go put that parameter in. Each line read in from the text file will result in one stop type object being added to the array above. Open the file for reading. You may assume the file exists. Loop through the file until there are no more lines. In each iteration, read in each line and split the stop data into separate items. Create a stop object with the information and add it to the array and update the counter variable appropriately. So nothing surprising there, but let's just call it string file name. Okay, and so then I want a first thing I want to do is to open the file. So it's scanner sc file equals new scanner new file name. And immediately it should, well, first of all, ask you to import scanner. Okay, don't just click things randomly here. You do need to make sure that it's the thing you're looking for. So, I mean, like for example, it says create class scanner. That's going to create your own scanner class, and you're just going to be really stuck then. So add an import. If you did do that, if I did accidentally click that and add a scanner thing here, it would be overriding it. You'd just have to right click and you'd have to delete. Okay. In fact, I'm going to do that with file. So it's going to say cannot find file. I'm going to say create class file. Done. Okay. And now you'll see it's just not going to work. So what I'm going to do is I'll just delete that, and we should be good. But really what I wanted to do was I wanted to import java.io.file. And finally then is I want to cannot inherit from scanner new file name. Okay, so I'm just going to start that again. Scanner sc file equals new scanner. So yeah, don't do what I did because it does not go nicely. Oh, I'm an idiot. Oh, I am an idiot. Sorry. The reason I was doing that is because I was trying to open a new class. And then so over here, I want to do not throw. I want to surround the statement or surround the block. Let's try catch. And there we go. And over here, this is just where I want to put my system.println file not found. Okay. Then while sc file dot has next line. This is where the brackets go. Scanner sc line equals new scanner of sc file dot next line. This really should be quite boring. You should have done it a billion times before. Sc line dot use delimiter. This is where I want to check my text file. So it's a comma. Okay, and then basically, so it is, I've got a name, a stop type, and then a root code. So string name equals sc line dot next. Then int s type equals sc line dot next int, and then finally string r code equals sc line dot next. I've used different variables to the ones in the actual class stop, just so that doesn't confuse you, but you're welcome to reuse the same name there. And then what I want to do is add it. So stop equals new stop, and we need to send it the name. Let's just double check. So the parameters go stop name, root code, stop type. So name, r code, and s type. And good thing I actually did check because it is in a different order to coming in from the text file. So do be careful about that. And then basically my stops array at size becomes equal to stop, and size plus plus. Cool, and that is all 9 marks there. Now, create a method called getRootWithCode that can take in a character representing a root code and a boolean representing whether or not the root is circular. This method should return a new root object with the corresponding attributes. The root object stop array should contain only the stops belonging to that root in the order they appear in the text file. Note that marks will be awarded for efficiency. For example, rereading from the text file instead of working from the existing array is not efficient. And you can't create any new public properties or public methods. I can create additional private properties and private methods as you find necessary. I think I'm going to do it without any doing of those just to make it nice and simple. But basically, this is where a lot of the confusion came in. In fact, I've just had someone ask me what on earth question 4.4 means. So public root get root with code, and this is going to take a character, so char root code. And basically, this is where what I'm going to do is I'm going to give you a code. So my code might, for example, be B, and I want you to return a root that with the name of the root, and then all of the relevant stops. So I'd want to have this stop because it's got to be skip that one, skip that one, skip that one, that stop, skip, skip, and that stop. So that's what my root would contain. So let's go to question 4.4. So first thing I want to do is, take in a character representing the root code and a boolean circular. Once again, I'm specifically choosing different names to the ones we've used before. You are welcome to reuse them as an entirely different methods, entirely different classes, in fact. Okay, so root r equals to new root, and I send it the root code and circular. And that, let's just go double check my root over here. That's what the constructor wants, a root code and then a boolean. I just want to see why we've apparently got an error somewhere in Tour Manager. Okay, it's at the bottom because I haven't returned root yet. I can get rid of those 2 lines because they just came in when I added my try catch. Okay, not that you have to get rid of them. So far so good. The tricky bit is now I want to put all of the stops in. So, and this is where I'm going to use the is part of root. So basically, I'm going to go through the whole for loop. So for int I is equal to 0, while I is less than size, that's the size of my stops array. I'm going to go I plus plus. And now all I want to do is I also need a count. And you'll see why I'm doing this. The first int count equals 0. The first thing I want to do, because we don't have a size of our stops array, and because they said our stops array, okay, so we've got a stops array here that contains all of the stops. We're now going to create a root stops array, so just for a specific root. And because it's supposed to contain only those specific roots, I need to know how big to make the array. I can't resize it later. I can't do something like this where I just say make it huge and then have a little variable to count the size of it or whatever. Although you can if you did some weird copying and things, which I think that's in the memo, but don't stress about it. So what I'm going to do is I'm going to first go through the whole thing and just count it to see how big it is. So I'll go if stops I, so I'm going through my stops array, the whole stops array, every stop, dot is part of root code count plus plus. And if it's not, I don't do anything. I don't care. So this is just so I can know how big to make my new stops array. So now I'll make a stops array, and I'm going to call it root stops equals new stop. It's a stop, not stops. New stop count. Stop array. There we go. New stop count. Okay, so now this is the correct size, and so I'm now going to go through the loop again until size, and I'm just going to go if stops I dot is part of root code. I'm going to say root stops equals root stops at I. No, sorry. Oh. I need another variable here. Now again, in fact, okay, I'm going to go int. I could reuse count, but I'm just going to call it count2 or whatever. Root stops, make that equal to 0. So root stops count2 is equal to stops I. And then I increment count2. Okay, and then finally I want to go, if you take a look, root has got a set stops method, and remember they said would be put in later, so I'm going to say, where's my root? R dot set stops, and I'm going to send it root stops. And finally it needs to return it, so I'm going to return R. And that should be everything. Okay, let's go take a look at the memo. So I've tried to do it in, I think, the simplest way so you can understand what's going on. I think the memo got a little bit fancier, if I recall from the last time I looked at it. So that's question 5, we're going to skip. Question 3, there's our stop manager. They used a buffer breather rather than a scanner. It doesn't matter. So over here, so efficiency mark, file is never reread. Tick, no other public method creating a root or stop class to do any part of this method. So that's straightforward there. Any way to fix the array to the correct length. So the first one is to create the exact array and then do it. We did that. They reused count. Then they went through and they added them in there. That's exactly what I did. Alternative 2, create the same size array as all stops and then shorten it. That's using the array copy thing, which you don't need to know. It's a fancier thing. So what they're doing over here is they're creating a new array that's the exact same size as the original stops. They're going through and they just start adding things. So they just keep adding the thing there, and then they like copy the array to a new one, and they like only do as many things as count. Do not stress about alternative 2. You do not need to have used that at all. So what we did was perfectly fine. All right, and I think that might be the end of question 4. That is the end of question 4. Okay, question 5. We're now going to create a toString method for the root class that we use to obtain a string representation of a root in the following formats, depending on whether the root is circular or linear. All roots with no stops should be treated as invalid roots. Okay, so that's like, I mean, if you look at our text file, we've got B's, R's, and Y's there. So if I sent like in a P, then it would be an invalid. Okay, so, and then we've got a choice between whether it's a circular one and a linear. If it's a circular one, I basically go through 1, 2, 3, 4, 5, and then I end back at the start one. And if it's linear, this is where I go, do the whole, it's going to 1, 2, 3, 4, 5, and then back down 4, 3, 2, 1. Okay, and there we go. So I get to do that. So let's go to root, and I'm going to go /q5 public string toString, and I think so long if we understand what happened previously, how to build up the root, it's probably quite easy. So this will have a root code. So now the first thing I want to do is I need to say if, so because stops will be the exact size, the correct size, I'm going to say something like if, so stops is equal to null. So let's say stops just never got the stops here, so this is the root stops. So this is previously, like when you were doing over here, we were building our root stops things with all the stops. That's what is now actually inside the stops array here. So if stops is equal to null, or stops dot length is equal to 0, that should really cover every instance. I'm just going to return root code no, it's the variable root code plus invalid. Okay, else so now we know that things are valid. Let's just create a string called ret. I could have done the string ret over here and just set ret equal to that. In fact, let's do that. That's probably what you're more used to. So let's do that. So string ret is equal to empty string over here. Then over here, I'll just say ret if it's null or whatever, ret equals that. Then we can just return ret, and that's all our return paths taken care of. So else what we do is we say over here, and now all I do is I just go through the stops. So if is circular, then I want to go for going from I to stops.length. What I do is I say ret plus equals, and then it's the root code. Oh, sorry, first bit, what I want to do is I want to say ret equals root code, well, don't know what I was deleting. So I want to first display root code dash circular, so ret equals root code plus dash circular, and then I have to start adding the root. So stop one in stops two string format. So I do that, so I return, I just want to see what the stop is returning as a thing. It's got stop name. Okay, so I want a number. So this number is going to be a bit of a, actually this number is not going to be a pain at all. This is just the same as, this is just I plus 1. So I return I plus 1 plus, so that's going to give me, like on the first one, it's going to give me 1, then a 2, then a 3. I go return I plus 1 plus stops dot toString. Okay, so that should go through, it'll go through the whole route, it'll give me 1, 2, 3, 4, 5, or however many stops there are, and then finally I want to go back to the beginning again, so just say ret plus equals, and then what number should it be? And so if you take a look, if in this case there's 1, 2, 3, 4, 5 stops, it's actually, sorry, we've gone back to stop 1 again, so the number is easier, so I'll just add 1 plus stops dot, oh, I'm an idiot, this should be stops I dot toString, and this is going to be stops naught dot toString, because once again I want to add onto it the very first stop. Okay, and so then else, so let's say it's not circular, so this is the linear, this one gets a little bit fiddly. So once again it's root code linear, and I think honestly it might be easiest to just do 2 for loops, just getting the numbers. Otherwise you can do it with a little bit of a mathematical calculation, but I think the easiest is I go for once again int I, I'm being lazy, for tab gives me that. Once again we want to go up to but not including stops.length. Okay, and basically I add to my toString, once again it's I plus 1 plus stops I dot toString. Now that I see I've like basically copied this code, I'm actually thinking I could have done this bit as one thing, and then just in the else just done either added that. In fact, I suspect that we're going to lose marks if we don't do that. Although no, we did have to set the circular there, so whatever. Sorry, ret plus equals, and then so this will give me, although 1 to 5, I now need to go backwards, so I now go for int, and the thing is I don't repeat the last one, so I'm going to say I is equal to stops dot length minus 2. I want to keep going while I is greater than or equal to 0. I want to go I minus minus, and once again ret plus equals I plus 1 plus stops I dot toString. It's suddenly occurred to me that I haven't done any testing, which is a very bad idea. You definitely want to test as you go along. But yeah, let's take a look at the memo. I suppose that'll be our testing, just looking at the memo. Obviously you can't do that tomorrow. So there we go. So first thing we've got that we're doing the invalid. So also accept less than or equal to 0, and just adding the and equals null is fine. No route, so efficiency, two no route processing for invalid stops. So basically you have to put it over here right at the beginning to get two. One, an invalid check is done, but there is unnecessary processing or checking of route types. This would be like we go through the whole thing and then we go, oh hey, if stops with length was 0, then make it invalid. So that's cool. And so there's our efficiency. So over here, they're just adding on a circular or linear. Okay, and you can see that I would have lost a mark for efficiency. I didn't think of doing this here with two is circular things there. So here they're doing the thing, they're just adding the right stops. I forgot to put new lines everywhere. So let's do that. /n. I would have seen that in the testing. And then finally over here, you can see I called out the repeated code, and I said I was going to be penalized for it, but you know, I'm sort of rushing through this, so I didn't want to go through that. And there we go. That's just adding all the stops going the right way. Then if it's circular, you add the first stop again, and otherwise you just add all the rest of the stops in reverse. So everything was cool there. So we're going back to the question paper. So now look at question 6, and here are we. So if you wait until here to do your testing, I mean, and you made a mistake, you're going to be in a lot of trouble. So I strongly suggest that you rather, what I would do is do the stop class, create a little test class, see if that works, then do a root class, create a test class, see if it works, and go like that. So now I want to tell you UI, so new Java class to a UI. Once again, I do not want my name there, but I do want my exam number. Okay, and create a simple user interface called TUI that allows simple output. So that is literally just PSVM. That's it. Declare and instantiate a tour manager object. So tour manager TM equals new tour manager. At the appropriate place, the text file data.txt should be used to instantiate the objects. So that is our parameter. If you take a look at tour manager, we needed a file name as a parameter in the constructor. So that is data.txt. Cool. Then declare, and we've done that. Write code to acquire two root objects from the tour manager using the method getRootWithCode. That we're creating question 4.4. The first is a circular route with root code R, and the second is a linear route with root code Y. So root R is equal to new root, and we send it the character R and circular. I'm an idiot. We send it true because it's circular. And the next one, root, so Y, new root, and that's we send it a Y. And it is not circular, so send it false. And then write code to print out both roots in the two-string format. So south R, south Y. I should maybe do something like, does the root thing print out a nice header? It does. Okay, so I don't think I need a header there. Let's go look at the memo. Question 4.1. Oh, we've done all of that. Oh, maybe I looked at that. 7. Oh, no, that's 7.1. That's not us. To a UI class, there we go. New manager. We're declaring those things there. We're printing them out. Cool. I keep forgetting where the question paper is. And finally, question 7 goes on. All right, so in the tour manager class, create a suitable method that takes in two root objects as parameters. The method will work out the stops that are common to both routes. The method should return a string listing the common stops in separate lines. Each common stop should be included once in the stop class two-string format. So here are some examples. So if I give you two linear routes over here, common stops are 5, and we return its other stop 5. That's literally just the println from the stop. And over here, there's a common stop 16. And here's a linear and circular route. They've got 24 and 25, and we return that. Okay, that actually doesn't look too bad. So what I need to do is I need to go through the first route. Well, let's see if we've got any methods. Doesn't say anything about creating, but I just want to go through routes. Get stop at. So we're going to be using this. We're going to go through all the stops. And there's nothing here to say. I'd be tempted in this class here to add a public method, but I think they did say you're not allowed to add any, so I won't, because that would actually be quite easy, but so we'll do it all in Term Manager. And I don't think it's too bad. So create a suitable method that takes in two root objects as parameters. Okay, so we're going to call it public string common stops, and we'll have a root R1 and a root R2. Okay, and then basically, do we know the length of the root? So we've got a stops. We don't have a length of the stops. They did also say you are allowed to have. So what I'm looking for, because basically it's a tour manager. So now we're not allowed to add public methods. I think it's just somewhere in root. Yeah, no additional public attribute method should be created. You may create any additional private method as needed. Okay. And what I'm wondering is, because what I would like to do is I would like to go through. So what I was thinking initially is that I'm going to go through route 1. I'm going to go through all of the stops from route 1, and I'm going to see, do any of those stops exist in route 2. However, I can't get the size or in fact the stops, because the only thing I've got is set stops, get root code, and get stop at a specific thing. And I was planning on using this. So what I'm now thinking that I do is perhaps what I've got this array of stops. I go through my array of stops and I just say, is that part of root? Is that part of a root? And I think, in fact, that's a better way to do it. I've explained that terribly, but you'll see when I start coding. So string ret equals nothing. And we're going to return ret. And I actually think it's going to be quite easy. So I'm going to go for I is less than 0, I is less than size. And what I'm going to do is, instead of going through all the stops in route 1 and then all the stops in route 2, I'm going to go through all of the stops in my stops array, and I'm going to see, is that stop in route 1 and route 2? So if oh yeah, because we've got a root code. Please tell me there's a get root code. There is, thank goodness. Right, so if stops I dot is part of root R1 dot get root code, and stops I dot is part of root R2 dot get root code, then what I want to do is I want to go system.println. No, don't. Oh, wow. I want to return, add to my return stops I plus a new line. Cool, and I actually think that's that. In the tour UI close, use the method closer to do the common stops. So over here, I just call, and then you get this mark even if you couldn't get the previous question. I literally just go south. What's it called? It was tm dot common stops of R and Y. Okay, let's go look at the memo. So if you look at the memo, you'll see over here system where they called it workout common stops, root R, root Y. Cool. Let's go look at the 7.1 workout stops. Okay, so correct public method header. Any name must be public. Takes in two objects, returns string object. Marks allocated. Loop to go through route 1 stops. Test if it also belongs to route 2. Efficiency, no file rereading, no other method created. String concatenation done correctly, and then correct return. So working with the two routes. So, okay, they're doing count equals 0, R1 did get stop at count, and while S is not equal to null, so that's how you can actually get around not being able to get the count number. They say if S is part of route 2, get the route code and then return it. And then I think this is the one that I did, where I just went from 1 through the all stops array, and I checked to see if they were there. Cool. So this alternative, basically what they were working on is, if you remember the get stop at, so they said we're always going to start a get stop at 0, and then it eventually returns null when it's an invalid stop. And the reason they did that is that there is a way of doing this without any other things. So what I could have done is I could have just said, right, let's go through R1 and say I'm going to get stop at 0, then 1, then 2, then 3 until that's null. And each time that's happening, I want to see if it's part of route 2. I actually think this method we did was probably easier to understand. And that's the prac. So yeah, feel free to, if you've got any last minute questions, feel free to WhatsApp me. Yeah, I suppose if you are, I'm not going to put my phone number here. If you need my number, the matric IT boys in my class have it, so you can get it from them. Cool. Right, I'll upload this now.